Hello everyone, welcome to today's class. The topic that we are going to see today is operators and expressions. So this is going to be part 1 of our lecture. The remaining portion will be covered in part 2. So let us begin by seeing what are C tokens. In the passage of text, individual words and punctuation marks are called tokens. Similarly, in a C program, the smallest individual units are known as C tokens. So here I have listed some of the types of tokens. Okay, so here we have the keywords, the constants, the strings, the identifiers, the operators, the symbols. So these are different types of tokens, and under this token you can see some examples that are given. So for keywords we have float and y. For constants we have minus 16.5 or 100. For strings we have abc and year. So all of this are smallest individual units, and these are also known as C tokens. Now moving on to operators. So what is an operator? An operator is a symbol that directs the computer to perform certain mathematical or logical manipulations and is usually used to manipulate data and variables. Say for example, here we have two variables a and b. Okay, these are also known as our operands. We are basically doing a summation operation here by using the plus symbol. So this plus is our operator. Now we have some different types of operators in C. So as you can see, we have the arithmetic operator, the relational operators, the logical operators, the assignment operators, the increment and decrement operators, the conditional operators, the bitwise operators, and the special operators. So we are going to see what all of these operators do and how they are used. Now let us begin with the arithmetic operators. So arithmetic operators are of two types, unary or binary. So unary operators are for one operand, as the name suggests, and binary is for two operands. Okay, so you can see an example here. We have three variables, right? A, B, and result. So here we are basically doing the summation of A and B and storing the summation in the result variable, right? So here A and B are our operands, and the plus symbol is the operator. Okay, and here this plus operator is binary because it is used for adding two operands. Okay, it is used for two operands, which is A and B. Okay, now let us see what are some of the operators that we have. So firstly we have the plus, which is different from this plus because this plus is the unary plus and its type is unary. It means that it will only require one operand, so which is A. As you can see here, we are using one operand and the unary plus symbol before it. So this plus A means it is plus 11. Okay, the result will be plus 11. Similarly for this operator minus, this is the unary minus, and minus A will give us minus 11. Then we have the plus. This plus is basically a binary type. Okay, and this is used for addition. So the two variables that we previously had, A and B, which was 11 and 2, okay, if we add them we will get the result as 13. Here we have minus. Now if we subtract the two variables A and B, okay, we will get 9. So this minus is used for our subtraction and the type is binary, right? Now we have the star symbol. This star symbol is used for our multiplication. So if we use the two variables A and B, A, the star symbol, and B, then we will get the result as 22 because this will simply multiply. Okay, and as you can see, all of these operators are binary since they require two operands, right? So they all require two operands. That is why this type is binary. Then moving on to this symbol, this is the slash symbol. If we use it, it will give us division. Okay, so this will perform the division operation. Now you can see that here A divided by B gives us 5, but A is 11 and B is 2, so it should have given us 5.5, right? But since the type of A and B are integer types, and if we are storing this result in this result variable, okay, which is also an integer type, so the result will also be of int data type, right? So the 0.5 will be discarded because the 0.5 will mean that it is of a float data type. But since the result is also of integer data type, the result that we'll be storing will be of integer type, that is 5. Okay, then lastly we have the mod. mod operation. So this mod operation basically is the remainder operation. So if we have a mod b, which is 11 mod 2, so this 11 mod 2 will give us the result 1. Why? Because if you divide 11 by 2, the quotient becomes 5, right? Okay, and the remainder will become 1, right? So 11 divided by 2, so you get 2 into 5 is 10, and 10, if you subtract 10 from 11, you get 1. So this is the remainder operation. So this mod operation is basically used for getting the remainder between the two operands. Okay. Okay, let us move on to the precedence of the arithmetic operators. So as you can see here, we will be seeing two rules, the precedence rule and the associativity rules. Okay. So what is the precedence rule? The precedent rule decides the order in which different operators are applied. Now, what is the associativity rule? This associativity rule decides the order in which multiple occurrences of the same level operator are applied. So we are going to see what these two rules stand for in our examples as well. But first, let us see the precedence order from this table here. As you can see, I have listed the precedence of the arithmetic operators. The first one is the unary. Then we have the multiplicative and the additive. So unary is the unary plus and the unary minus. The multiplicative is the multiplication, division, and mod operation. And the additive is the addition. This is the addition and this is the subtraction operation. So the precedence of all of this operator is from highest to lowest. So that means that unary has the highest precedence, followed by multiplicative, and in the last we have the additive, right? So here you can see I have stated their associativity as well. So for unary it is from right to left, but for multiplicative and additive it is from left to right. So let us see how these are applied in our examples. So in these examples we are going to see the precedence rule application, right? So let us see how the precedence rules apply here. So in this expression you can see I have I plus j into k. So I have two operators here, plus and multiplication, right? So whose precedence is highest? Obviously the multiplication precedence is highest, so the j into k will be performed first, right? So the j into k will be performed first. After we have performed this, then the result will be used for this addition here, for this operator here. Okay. In the next example, you see we have minus I into minus j. So here minus I and minus j are unary operators which have the highest precedence, right? So this minus I and minus j will be calculated first, and then the multiplication operator will be done. So as you can see, the minus I and the minus j operators are done first, and I'm using these brackets to indicate which operators are being done first. Okay. So here in the third example, you can see we have the unary minus unary, right? Then we have the addition, and then we have the division symbol. So here obviously the unary operation will be done first, then the division operation, and lastly the addition operation, right? So as you can see here, first the minus operation, the unary minus is done, then the division is done, and at the end we will do the addition. Okay. Now let us see some examples that makes us understand how associativity is implemented. Now here you can see that we have I minus j minus k. In this expression we have two operators which are minus, right? They are the same operator, right? So we have two minus operators. So now we are confused that in which order are we going to solve this, evaluate this expression. So as you can see here in this additive for minus, I have given here from left to right. The associativity is from left to right. So this is where you will implement your associativity rule. So associativity rule decides the order in which multiple occurrences of the same level operator are applied. Here you see multiple occurrences of minus. So the associativity states that we need to go from left to right. So firstly, the left part, the left operands, okay, of the left operator will be evaluated first. So my I minus j will be evaluated first since we are going from left to right, okay, for minus. Okay, now we have another example. Okay, and here we have unary minus and unary plus. So here what we will do, which one we will evaluate first? As you can see, for the unary we have the associativity from right to left. So here what we will do, we will go from right to left. Okay, So here we are going from right to left. We will be calculating the plus I first, then the minus I. So this is our right associative, okay, going from right to left. Now moving on to the relational operators. So these operators are used for comparing operands, okay, and the result that they will fetch us is either true or false. So true corresponds to 1 in computing language, okay, and false corresponds to 0, okay. Now here we have two variables a and b of data type integer whose values are 9 and 3, okay. For a it is 9 and b it is 3, as you can see, and the operators you see are listed here, okay. So the relation operator, the first relational operator is this one, which is the less than, okay. So here is a less than b. So a is what, 9, right, and b is 3. So is 9 less than 3? No, 9 is not less than 3, so the result will be false, which is 0. Similarly, we can see that we have less than equals to here, okay. This symbol is less than or equals to. So here the or is important, okay. You will see why. So you can see that here a less than equals to b. So is 9, this 9, is it less than b? No, it is not. Again, is this 9 equals to 3? No, it is not. So since both of these statements are false, we will get the result false, okay. Now here we can see the greater than symbol, okay. So this is the greater than symbol, this one. So here a is greater than b, which refers to 9 greater than 3, which is true. So that is why the result will be true. Now for this statement, you can see greater than equals to. So is 9 greater than or equals to 3? Yes, 9 is greater than 3, but it is not equals to 3. Since one of the statement is true, the result will fetch us true, since we are using or here. So if any of this statement is greater than or equal to is true, okay, then the statement will also be true, right? Since we are using or here, okay. Then we have the equal to, that is the equal equals, right? So the equal to symbol is referred to as equal and equal by using 2 equals to. So is a equals to b? No, 9 is not equals to 3. So that is why the result is false. Okay. And lastly, we have the not equals to, which stands for the exclamation equals to symbol. So this symbol refers to the not equals to symbol. So is a not equals to b? Yes, a is not equals to b. 9 is not equals to 3, right? It is not equals to 3. So that is why this statement is true. So this not equals to is written as exclamation equals to in our coding language, right, in C. So moving on to the logical operators. So these operators are used for implementing logical expressions. The result from these logical operators will also be true or false, okay. So for the logical operators, what we have this and symbol, which refers to the logical and. Then we have these two symbols, okay, standing symbols, which refers to the logical or, and then we have the exclamation symbol, which refers to the logical not. So here let us see the truth table for the logical and the logical or, okay. So if a or b is 0, if any one of them is 0, then the logical and result will also give you 0, okay. So as you can see, when we have 1 0 here, we have 2 0, that is why the result is 0. Here we have 1 0, that is why the result is 0. Here we have also 1 0, that is why the result is 0. But when we have two ones, the result will be 1. So for logical and, if any one of the variables is 0, the result will be 0, and if both of them or all of them are 1, then the result will be 1. So as you can see, for either of these two variables, if there is a 1, then the result will be also 1. As you can see here, for the first two variables, the result, both of them are zeros. That is why this will be 0 as well. But if you have only 1, okay, for any of these variables, the result will be 1, okay. So this is pretty simple, right? Now, as you can see, I have listed an example here. Now for our logical AND, okay, we are seeing that I have declared some variables, a equals to 9, b equals to 3, c equals to 3, and d equals to 0, okay. So in this example, a less than b. So is a less than b? Is 9 less than 3? No, 9 is not less than 3, right? So if 9 is not less than 3, it means that this will be 0. Okay, this result will be 0 since relational operators also give a return true or false. It means 1 or 0, so a less than b will return us 0. Now, is b equals to c? Yes, b is equals to c, which means that the both of these variables are same. So this result is true, this statement is true, so it will give us 1, right? And this will give us 0. So if you go to this 0 and 1, you can see that the result will be 0. That is why the result is false. Why is it 0? Because for logical AND operation, if any one of them is 0, then the result will be 0. But if the same example is used by our logical OR, what happens then? You have a 0 here and a 1 here. But since in our logical OR, if we have any 1, then the result will be 1, right? So as you can see here, if you have 0 and 1 for logical OR, the result is 1. So that is why the result will be true here, okay? And lastly, we have the logical NOT. Okay, this is the logical NOT. So by this logical NOT basically converts the 0 to 1 and the 1 to 0. Okay, so here previously we had d equals to 0. So if you use not d here, so this logical operation, logical NOT, is used before the operand. Okay, so if you use this operation here, then the result will be true since d was previously 0, and using this operator it converted the 0 to 1. That is why the result will be true. Now let us see the relative precedence between our relational and logical operators. Okay, so here you can see that I have given the precedence. Okay, so here from the highest to lowest we have our precedence set. So meaning that this is our highest precedence, then we have this precedence, and the lowest precedence is this one. So this is our highest to lowest precedence. Okay, the top one has the highest, and then it goes onward like that. Okay, now you can see here we have the logical NOT, which is of the highest precedence amongst the relational and logical operators. Okay, and its associativity is from right to left. Except for the logical NOT, all the other associativities are from left to right. So keep this in mind. After the logical NOT, we have the relational operators, which is the less than equals to, greater than, or greater than equals to. Then after this, the precedence that comes is the equality, which is the equal or not equals to. Then we have the logical and afterwards we have the logical OR. Okay, so using this table, let us solve this example. Okay, so you can see the expression that I have given here, which is a less than b, and which is the logical AND operation. Then we have b equals to c, which is the equality operator, right? And then we have the logical OR and the logical NOT operator. So from this table, you can assume that the logical NOT operator is of the highest precedence, right? So what we will do, we will implement, or we will perform the logical NOT operation first. The first operation will be this logical NOT, right? So I will be showing these examples using a bracket. So this operation is being done first since the precedence of logical NOT is the highest. All right, and the associativity is from right to left, but we don't need associativity here since multiple occurrences of NOT is not here, so we don't need it now. We only need the precedence now. Okay, now the next thing that we will be doing is the less than operator. So why? Because the relational operator has the second precedence after NOT, right? So that is why we will be performing this operator. Okay, after doing this NOT operation, we will be performing this operation, right? So after we have performed these two operations, what should we do next? We have this and equals to and OR, right? So here from this table, you can see the equality comes next. So we will be doing this operation next, the equals to operation next. So as you can see, we are doing the equals to operation next, right? Then we have the logical and the logical OR operation remaining. But in the table, the logical AND has the higher precedence over logical OR. So we will be doing the logical AND operation first. You see, we are doing the logical AND operation first. So after this, we have only one operation remaining. That is the logical OR, and we will finish our evaluation by completing the logical OR operation. As you can see, I have used the bracket here. Now moving on to the assignment operators. So what are these assignment operators? These operators are used for storing a value into a variable. So the syntax that I have given here, v equals to e, here the equals to is our assignment operator. So what we do is we evaluate the expression e, okay, and copy its value to v using this assignment operator. So here this e can be a constant, a variable, or a more complicated expression. Now as you can see here, I have I equals to 5, right? This is of integer type I, and this 5 will now be stored in I, right? Then we have j equals to 6.5. Now here j is of integer type, right? So instead of 6.5, j will now be 6. This 0.5 will be discarded since this is of integer type, okay? And now for k, we have 10 into I plus j. We know I is 5 and j is 6. Now here you can see that assignment has lower precedence than arithmetic operators. So these operators will be first performed. So this 10 into I will be performed first. So what is 10 into I? 10 into I is 5, right? So 10 into 5 is 50 and j is 6. So 50 plus 6 is 56. So k will now be 56, right? And after this operator is done, this 56 will be assigned to k. That is why k is 56. Now assignments can be changed together. As you can see, I equals to j equals to k equals to 0. It means that all of these variables will be deemed as 0. Okay, they will be stored as 0. Okay, but how is this assignment done? This assignment is right associative. It means that it will start from the right and go towards the left. So firstly, the variable k will be assigned. Okay, firstly k will be assigned. After k, j will be assigned to 0. Okay, then after j, I will be assigned to 0. So k is 0, then j will be 0, then I will be 0. So one thing that we have to keep in mind is about the type conversion in chain assignment. So here we have two variables, I and f. Now if we want to say declare a chain assignment, and we write this statement, f equals to I equals to 33.f. Now I is of integer type, so I will be storing the value 33 and it will discard the decimal points, right? Now this 33 will be used for f, right? So f will be 33. So f will be 33, and since f is float value, it will be also having the point 0 here, but it will not be 33.3. Since I'm assigning the value 33 to f, f will automatically be assigned as 33.0. So we need to be careful. Okay, so if we wanted to assign it, it should have been f here and I here. Okay, so f then would have been 33.3 and I would have been 33. Now moving on to the compound assignments for assignment operators. As you can see in this table, I have given a equals to a plus 1. So this is simple, right? You are just incrementing the value of a by 1. You're just adding 1 to a and storing the value of a in a again, right? So you can write this in a simple manner as well. If you would have used a plus equals to 1, it stands for this. Okay, so this is the compound assignment. So by this statement, it means that adds a to 1, storing the result in a. Okay, so similarly, if you have this expression a equals to a minus 1, you also can write it like a minus equals to 1. So what will this do? It will subtract 1 from a, storing the result in a, right? So in this examples, you can also see that you can use the compound assignment. So a equals to a into m plus n. So in this case, what you can do is a, then the multiplication sign, then equals to m plus n. So it will multiply a by m plus n, storing the result in a. Similarly, for this example, a equals to a divided by m plus n. Here what will be happening is you can use this compound assignment so that you can divide a by m plus 1, storing the result in a. Okay, so similarly in this example, you can use the percentage symbol before the equals to assignment symbol, and you can do this, you can implement this statement by writing this only. Okay, so this is also known as the shorthand assignment. So by writing this, you don't have to write this entire thing, so you can save your time, right? So instead of writing a equals to a plus 1, you can simply write a plus equals to 1, which means the same thing. So this all of this are the same, right? You can use either of them, but you can use this ones to save time as well. Thank you. This will be all for today's class. Hope you have understood and enjoyed the class as well.